3-phase unbalanced loads, right? So we'll try to solve one problem on this. So let us assume that you have a star connected so this is 120 at an angle 0, right? And this is 120 at an angle minus 120 degrees. And this one is 120 at an angle plus 120 degrees. And this value is J5 watt. This value is J5 watt. So J5 ohm. So, and this is minus J10 ohm. And this is 10 ohm. For this, calculate line currents. Calculate line currents. The total complex power absorbed by the load right. Total complex power, in other words, so find out the complex power. Okay, find out the complex power. So how to solve these kind of problems? How to solve these kind of problems? Any guess? So how to solve these kind of problems? Any idea?
Sir,
first you have to find out the real power, sir, using V line and I line.
So how you calculate the first line current?
Sir, V
We studied this kind of
line
things,
by
right?
resistance.
Can we apply mesh analysis for this?
Yes, sir.
Okay.
yes,
So
sir.
you can apply a mesh analysis. So assume this current is I1 and this is I2. Okay. So let us assume that this is line current IA and this is IB, and so this current is IC. Okay. Right. So what is the first equation? If you assume that the current is I1, so what is the first equation?
Sir,
Plus 120 angle of 0 degrees.
Plus 20. So this one is right, 120 at an angle. So how it is going from plus to minus?
So minus 120
That
at
is
an angle,
minus,
minus
sir.
20.
Minus 120 at an angle, minus 120 degrees, plus 120 at an angle
120.
0. Yes.
0 degrees.
No, this is equal to
5 J5I1.
J5.
J5 I1.
yes. Next,
Sir, 10 into
Plus 10
I1
into
minus
I1
I2.
minus I2.
10 into I1 minus I2, sir.
yeah, good. So this is equation 1. Similarly, you need to formulate the other equation by using this minus. You tell me. So this one is, what is the first equation or the second equation? So for this, what is for this? So how this current is
Minus-
flowing? So how this current is
plus
flowing?
at an angle minus
I
120
plus
degrees.
I20. So this
Minus
is the one,
120
right?
at an angle 120, sir.
Minus 120 at an angle 120, right? So this is current is leaving here, plus 120 at an angle minus 120, so equal to, what is the first term? 10 into I1 minus I2. Agree?
I2,
Agree?
I2
So
minus
I2
I1.
minus I1.
I2 minus I1, sir.
Yeah, I2 minus I1 plus minus J10. Okay, minus J10 into only I2.
Yes, sir.
Okay, so this is equation 2.
Sir,
Yes.
because the uh, elements are means the resistors circuit are not balanced, so that is why we are not directly using the formula V line is equal to V line by impedance is equal to I line.
Yeah, that's why. So this is unbalanced load, right? We
Yes,
already
sir.
discussed in previous class. So
Yes,
this
sir.
is
That's
unbalanced load. So in that case, you cannot directly write. So this
yes,
is voltage, right? So this voltage will not directly apply here,
yes, sir.
because of that unbalance,
Understood, sir.
right? So if you solve this one, right? If you solve this one, so I have some answers. You can solve it at your home. So it will be 56.78 amperes. So no angle here, and I2 is 42.75 at an angle 24.9 amperes. These are the solution for this. So is these the line currents? So these are not the line currents, right? Exactly. So how to
Yes, sir.
calculate the line currents? How to calculate the line currents then?
Sir, line current is IA only.
IA is equal
minus
to
IB.
I1, sir.
So IA, so in this case, the first current, so both are same, right? I1, IA,
Yes,
both are
sir.
same, right? So this is equal to how much? It is 56.78 amperes. So what is IB?
I2 minus I1, sir.
I2 minus I1.
I2 minus I1.
So tell me, what is I2 minus I1?
For I1 angle is 0, sir.
Hmm.
For I1 the angle is 0.
No, yeah, 0 only.
Okay.
For line currents, we have to subtract, no, sir, IA minus IB.
These are the line currents only, right? Why to subtract? So whatever this current is flowing here. No need to subtract. So this is IA, right? And this is IB, and this is IC. No need to subtract. But we assumed that this loop current is I1 and the below loop current is I2. So that's why we need to calculate IB equal to I2 minus I1. Understood?
IB is 25.46 at an angle 135 degree.
25.46 at an angle 135 amperes. Right. So what is IC? What is IC?
Minus I2, sir.
Minus I2, right? So what is minus I2? What is minus I2? So what is minus I2 of this one?
270 minus 24.9, sir.
What is minus I2 here?
It's 42.75.
42.75 at an angle of
Hmm.
254.
Two? plus 254 or minus 250. So this one, right? So this is how we will calculate. We need to subtract with minus 180, right? So that gives you the minus number. You subtract this one with minus 180. So how much you will get? Minus. How much you will get?
150.
155.1.
150 minus 155.1. This is how you will do that, right? I2 minus I2. You're aware of this, right?
Sir.
Okay. Okay, no?
Yes, sir.
Right. So next, so how to calculate the, so these are the line currents over, right? So how to calculate the powers, or how to calculate the complex power or power. So earlier case, we have some formula, right? So we have some root 3 V line, I line, cos theta, right? So this is the power formula. Okay. And Q is same thing, but sine theta. And we have complex power S equal to P plus JQ, right? Agree?
Yes, sir.
Yes, sir.
So this is equal to 3 into V phase into I phase star conjugate, right? This is the complex power. Agree for that? What is the complex power in single phase? V phase into I phase, right? I phase conjugate. So in case of 3 phase, it will be 3 into V phase, I phase, right? Agree?
Yes, sir.
Okay. Right. So this also can be written as, so this V phase and I phase, if you have that, if you know the current, so this also can be written as. So now, so same formula will be acceptable here. Is these formulas are acceptable here? So these formulas are acceptable here. The question is,
Yes, sir.
why? Why these are acceptable?
Because we have given instantaneous polarity, sir.
So this is for balanced system, right? So why we are using 3 here? So what exactly we are doing is we are measuring the single phase power, right? And we assume that the system is balanced. So that's why we are multiplying with 3. Okay. So here how we are calculating the power is 3 into V phase, I phase, cos theta. So here if this is the cos theta, which cos theta you will consider? So this one you will consider, this one you will consider, this one, which one you will actually consider? Nothing, right? So because it is a unbalanced system.
Different for different, all three, no, sir?
It is A phase you have different power, B phase you have different power, and C phase you have different power. Agree? So because in this, what is the current it is flowing here? So this 56.78 is flowing here. So whereas here, so the power is IC, right? So 42.75 in this and 25.46 in this. So eventually the powers will differ. So now we have to calculate the A phase, B phase, C phase powers. A phase, B phase, C phase powers. So if you know the current here, so this current is 56.78, its magnitude 56 point. So what is the current that's flowing here? Or what is the power it is there in this circuit?
56.78
So
whole
we
square
have that
into
I
J5.
square into, right, I square into this J5, right? So what is I square here?
56.78 whole square.
56 point. So this is the power in A phase. So how much you are getting here? How much you are getting? What is it?
So 16 at an angle. So 16J kilowatt.
16J?
Kilowatt. Means
Kilo,
16,119 value is there.
okay, that is its power, right? So what is the power of SB? B phase power. So B phase you have this resistive load, right? So how much current is flowing in this B phase? So this is the one. So what is its magnitude? 25.46 volt square into 10. Agree?
Yes, sir.
Yes, sir.
How much it is?
6.23, sir. 6.23 kilowatt ampere.
It's
6.48, sir.
6.48
6.48, sir.
Kilowatt.
Kilowatt.
This is in VA only, right? So we are using this Z only. So this is VA only. We'll SB you are calculating, right? So what is SC? What is its magnitude? What is C phase current? So that is 42.75 square into what is its value? Minus J10, right? So how much it is?
42 points.
Sir, minus 20J.
Minus?
20J.
No, it's not 20.
Sir, kilowatt. The kilo.
1.827.
Yeah, minus 18.2 kilowatt.
18.27.
Minus 18.27. J
Minus
also.
18.27
Kilowatt ampere.
Kilowatt.
right. The formula is very simple, so don't confuse that. So if you have this R value is there, so you have some JX value is there. Okay. If this current magnitude is I, this current magnitude is I, right? So how to calculate this S? So it is I square into R plus JX. Simple. I square into R plus JX. What is R plus JX, right? So if this S is, if this is not there, if the only resistive element, so how we'll calculate this if this is the current? So what is the formula for that?
I square R, sir.
I square R, right? In the same manner, it is R square plus, if this only, you have only resistive,
Sir,
so only component is there. So it is only this, this will be absent. So here you have I square into plus JX. For
sir, I have a
example,
doubt, sir.
yes.
Sir, here we are using I square R because in star connection, I phase and I line are same. That's why we are using. Or otherwise, generally we can use a V square by
See
R
here,
also here.
no. What is the current that flowing through this element?
56.78, sir. IA.
So that's why we are using this, right? If it's delta connection system, so unit that load may be different. Okay.
In case of delta connection, we have to use we can use this one same this one also, sir. I square R.
Yeah.
Okay, sir.
You have that I is the current that flowing through the element. Okay. So this is I means, so this is flowing through the element. Simple. If element is there, some resistance is there, right? If some I current is flowing, so it is I square R. If this is Z, so this is I square into Z. If only resistance, so it will be your active power. If it is Z, so that means the current is in complex form. As simple as. Okay. If it is in this form, right? If you multiply this one, if you add this one is there, right? So what is its meaning is? Its meaning is 0 plus J16 kVA. Agree? So why 0 here? Why 0 here? Why 0 here? So here there is no resistive component, right?
Yes.
So similarly in the second one, so it is 6.8 VA kVA. So this kVA plus J0. So why J0 here? So here you have only resistance. Similarly for SC, so here the current that is flowing is 42.7. So this is minus J10. So here. So now what is power? Complex power SCA plus SB plus SC. So how much it is? If we add all these three, real parts and reactive parts, so what exactly you will get? So this is 6.48, agree? Plus J16 kVA minus J18, 18.27 kVA, right? So how much it is?
Minus 1 point.
Minus 2.27.
Minus J?
1 point, sir. 1 point.
No, 2 point only, right? Why 1 point?
2.27, sir.
2.27.
Yes.
It's simple.
2.27.
Right. So this entire thing is in kVA form. Agree? Because this is complex power kV. So this is in kilowatt. and this is in kVAR. Agree?
Yes, sir.
Okay. So if the question is, so what is the real power? So that is 6.48. So what is the reactive power? So that is minus 2.27. Is clear? Is clear?
In
Yeah. Yeah, yeah.
in case of SP, why we had not taken current in the complex form, sir?
Why? No, no. What you are saying?
Sir, in SB and SC, while calculating SB and SC, current should be taken in the complex form, no, sir, in the form of.
So here, this is element you consider here, right? Okay. So this element, so which is causing the reactive power or causing the active power, that you are considered.
Okay.
So we had different formulas for calculating the complex power, right? So one is, so S is V I conjugate. So you're aware of this one, right? Okay. Or you can also calculate I square into, so this Z. So this gives you in P plus JQ form. So this is also gives you in P plus JQ form. So complex power is basically P plus JQ form, right? So that's why it is known as complex power. So its units are kVA, kVA, small k. Whereas here its units are in watts, its units are VAR. So kVAR, simply volt ampere. It's clear?
Yes, sir.
Yes, sir.
So note down another problem. The unbalanced Y connected load, the unbalanced Y connected load has balanced voltages of unbalanced Y connected load has fed from balanced 100 volt ACB sequence sequence ACB sequence star connected supply.
Sir, Y connected means also star connected only, sir.
Both are same, no? Y or star.
Yes.
If the line impedance if the line impedance is 2 plus J3, the line impedance is 2 plus J3 ohm, calculate neutral current and neutral voltage. Calculate neutral current and neutral voltage. So we have star connected
Sir, what have you written after balanced 100 volts? Sir?
ACB sequence, star connected supply.
Okay, sir.
So how to solve these kind of problems? How to solve these kind of problems?
Mesh analysis. Sir.
So nodal analysis.
We have to use mesh analysis.
So what is the additional thing that is given here? If the line impedance is 2.J3 ohm, right? Okay. So how you will have to incorporate that? So here some. So what is this value? 2 plus J3, right? And its value is also 2 plus J3. Agree? And whereas here, so this value is also 2 plus J3 ohm. Agree? Agree?
Yes, sir.
Right. So now, so what is the voltage here? So remember, instead of showing voltage source like this, so I'm represented with what are these things? So don't be confused with these are not the inductances. So we already said in one class. So these are the machine windings. Sometimes we'll show either a source with positive or sometimes we'll show with windings. Okay. So this is how we will represent a AC source. So don't be confused with that. So what is this value? If this is 100 ACB sequence, so what is this voltage? What is this voltage? How much
100
voltage?
by root 3.
0 degrees.
100?
By
100?
root 3.
Yeah.
By
100
root
by?
3. Sir. Root 3.
Yeah, root 3 at an angle. How much?
0. 0.
Root 3 na sir.
Sorry, root 3.
0 degree.
So how much angle it is?
0.
0 sir.
0. Right. So what is this? Come to here. So what is the angle here? So how much this is?
120. Plus
100 by
120.
root 3. So this is ACV sequence, right? Plus 120 here. So 100 by root 3 minus 120 degrees. Is clear? So now how to calculate? So this current. So how to calculate this current? IA. How to calculate that IA?
Mesh analysis.
The line voltage that is sorry, the line impedance 2 plus J3 in that ACB, all the three phases is in series with the load, no, sir, like
Yeah.
15 ohms and
So
6
this
minus
is
J8,
comes
so we
in
can
series with
combine it
this.
there.
Yeah. So how much this IA is? Tell me anyone simple. So how much this IA is?
Sir,
What is the
line
value of that
voltage
IA?
by 2 plus J3, sir.
100. Right. If you apply KVL, this is simple things, right? So what is value here? You'll get the same current if you assume that this voltage, right? So this voltage is appearing across. So which elements? So this one, and this one, right? Agree?
Yes, sir.
Okay. So what is IA now?
100 by root 3
Mm.
0 degrees by 19 plus 6J.
100 by root 3 at an angle 0 by. So how much it is? 19 plus J6. Agree?
Sir, but for neutral line impedance, there will be one more current.
So that will comes in IB and IC, right?
Okay.
Right. So we are calculating the current. So which is relevant? The current, see here. So how many currents it will flow here exactly? Tell me in this neutral. How many
3
currents
currents.
it will flow?
3 currents, sir.
Right. So
3
which are
currents.
due to? So which are due to this voltage source, this voltage source, and this voltage source, right? We have 3 voltage sources,
Yes, sir.
right? So right now we are calculating the current. So that is flowing through this neutral with this first voltage source. So this is the one, right? Agree? Agree with that?
But sir, if we apply the KVL in that loop where IA is there, no sir, that IA loop,
Okay.
then while going through the connection between neutral to neutral, in that KVL equation, 3 currents will come, no sir?
Okay. I don't want to confuse you. Okay. So then, okay. So this, I think you have not studied the superposition theorem, no? Okay. So that's why you're confusing. You do one thing, right? So you assume that this is I1 current. Okay. Simple. So assume that. So we have another loop is there, right? So what is the another loop here? So which is forming another loop? So this element, so this one and this one, this is forming another loop, right? Agree?
Yes.
So I will redraw this one. So how many loops you have? How many loops you have? Okay. So what is this value? So these values are interchanged right now. So what is this value now? So this is 10 plus J5, right? Agree? And this one is C phase. What is the C phase value?
6 minus J8.
6 minus J8. Just I redrawn, I interchange the B phase, C phase magnitudes so that the loops are visible to you. Understand? Any confusion here? If any confusion?
Sir. No, sir.
Okay.
No,
So
sir.
now this current is I2 and this current is I3. Okay. So now you can solve for I1, I2 and I3. So now you can solve for I1, I2 and I3. Simple. Okay. So now you can solve for I1, I2, and I3. So once it is done, right? So what is the neutral current here? So what is the neutral current? This is neutral current, right? IN. So how to calculate this neutral current IN? So this is IB, and this is IC, and this is IA.
IA plus IB plus IC.
So IA plus IB plus IC, right? So what is exactly IA plus IB plus IC here? So this is equal to I1. So what is IB here? So what is this IB?
So minus I2.
Why minus I2? I3 minus I2, right? Agree? So this is IB, right? So IB is I3 minus I2 only. But IC
Okay,
is
sir.
Minus
no, no,
I3.
sorry.
minus
No.
8.
So no. Oh, no, this is only IP only, right? Okay, no confusion. This is I3. So this is I3 minus I2, right? So what is this phase? C phase. So it is minus I3. Agree? So how much you are getting? So I1 minus I2. So if you notice that, so this is the current IN, right? What is IN here? So this current is flowing like this. So this current is flowing like this, right? So what is IN here? Tell me. What is IN?
I1 minus
I1
I1 minus I2. Okay. So both are same only. If you calculate IA plus IB plus IC equal to IN, or simply, so this is I1 and this is I2. So this current IN is I1 minus I2. So from this, you can calculate this neutral current. So how to find the neutral voltage? If this voltage is N and this voltage is
2
N.
plus J3 into IN, sir. 2 plus J3 into IN, no, sir. Neutral voltage.
2 plus J3 into
Into I1 minus
So
I2.
this is the higher potential point, right? So it's N, capital N. So 2 plus J3 into IN. Okay. So it is 2 plus J3 into IN. Right. So now no need to solve this third equation. So this I3, I1, I2 values are sufficient. So to calculate the neutral voltage. So you have any questions here? So you have any questions?
If we are considering I1, I2, and I3 currents, we will get I1 minus I2 minus I3 also.
Where I1 minus I2 minus I3?
In neutral current.
In neutral current?
Instead of considering IA, IB, IC, we can consider the loop current and do it now.
So that you can do it, right? I1, I2 only were considered. Okay. So calculation of I1, I2 itself is enough, I'm saying. So no need to calculate for I3. Okay. Right. So this is one of the complex way, right? This is the most practical way. Okay. So this is the most practical way, right? So this problem can be slightly simplified, something like this. Right. So same data is given, right? Same data is given. So in this case, no need to, they're not asking for the neutral voltage, right? They're not asking for the neutral voltage. So this is the question. So this question is stopped here. The unbalanced Y-connected load has fed from the balanced 100 volts ACB sequence star connected supply. If the line impedance is 2 plus J3, calculate the neutral current. So assume that the neutral impedance is 0. So assume neutral impedance is 0. So in this case, so this impedance is 0, right? So this is connected like this. Agree? So line is having some impedance, but not the neutral. So line is having some impedance, but not the neutral. So how to calculate this? Now tell me how to calculate this. So in this particular case, so how to solve this problem? So how to directly calculate IA value? So what is the IA value here? Simple.
Again, loop analysis.
Why you have to use loop analysis here?
Oh,
100/3 at 0 degrees by 2 plus J3,
Yes.
17 plus J3, sir.
So 100 by root 3 at an angle
0
theta
degrees
by
upon
2
by
plus
17
J3
plus J3, sir.
plus 15 ohm.
17.
17 plus J3 ohm. Understood? So tell me what is IB? What is IB?
100 by root 3 at an angle minus 120 by
12 plus
6 minus 8J, sir.
So 6
6
minus
minus 8J plus
no,
2
this
plus
is,
J3.
8 minus 5J, sir.
so this one is right. So this is B phase.
Oh.
Okay.
No, sir, ACB, no, sir.
12
You
plus
told ACB, sir.
Hmm.
ACB you told, no, sir.
Yeah, this is B phase only, right?
Yes, sir.
Ah, okay, sir.
So
B
it will
phase, okay.
12 plus 2 plus J3 plus 10 plus
12 plus 8J,
J5.
sir.
10 plus J5, right?
J5, yes, sir. 12 plus 8, J8.
So 100 by root 3 at an angle minus
Minus
120
120, sir.
degrees by 2 plus J3 plus 6 minus
6
J8.
minus J8.
So now see how much it is simplified. Okay. So earlier case you have some complex method. So here, so the assumption is that, what is the assumption is that, so neutral current or the neutral wire or the neutral conductor resistance is 0. So in this particular case, so what is the neutral voltage here in this particular case?
0.
Neutral voltage is just 0 only, right?
0.
There is no point in calculating this neutral voltage. So this is 0. So whatever the earlier one, so that's most practical one, right? So we have impedance for the lines as well as we have impedance for the neutral. Okay, just to simplify our calculations or just to simplify the things, so we assume that this neutral current is 0, right? So that, see, you obtain all these three.
Sir, in the previous case, if the neutral impedance is also J3, 2 plus J3, then for IA also we have to consider mesh analysis, no, sir.
Yeah, we need to
But
use
in
mesh
that,
analysis.
but in the previous one, you have written IA is equal to 100 by root 3 divided by, you have added all that like a series connection there.
That's why we have some theorem called the superposition theorem. So that will be discussed in the next semester. So in that case, you have to use that. Okay.
Sir, but now we can use mesh analysis for the previous and now
Yes, yes.
just series connections.
So that problem can be simplified by using some different other techniques, but so far you are not studied that technique, right? So that's why we are not introduced it. Is clear?
Sir.
Yeah.
But
So
the
just
in
so
two cases,
remember,
IA
for the
not
previous
equal.
case, you have to use the mesh analysis. In this case, so this problem can be slightly simplified. Right. So next we have some small concept. So how to calculate the power? So how to measure the power? So if you want to measure the current, so which meter normally we use?
Ammeter.
Ammeter,
Ammeter.
right? In case of measure the voltage, so which meter you prefer?
Voltmeter.
Voltmeter, right? If you measure the power, so which meter you require?
the voltage into current.
Any
So
both.
which
Mul-
meter is preferred?
multimeter.
In case of DC circuit, right? In case of DC circuits, so it is easy, right? If you know the ammeter and voltmeter, so it is easy to calculate the power, because it is 10 amperes and this is some 200 volts. So this power is 10 into 200. Okay. So you have only one power, right? So that P equal to VDC into IDC. But in case of AC circuits, we have different powers are there, right? You have active power is there, reactive power is there, and apparent power. So these many different powers are there. So in this particular case, so how you will measure the power, right? So here in AC circuits, the power, active power, or P, that is, what is it? VRMS, IRMS, cos theta, right? So this is your power, right? Agree? So this
Yes,
can be
sir.
measured by using wattmeter. Have you studied this earlier or have you listened this earlier?
No, sir.
No, sir.
No,
So
sir.
this is the power can be measured by using wattmeter. So this measures only the active power, right? In watts power. If the reading of this one is 700, so that means the active power consumption is 700 watts. So from this, you have other things are there, right? Like calculating the reactive power or calculating the apparent power. So that can be done. Okay. So this wattmeter will measure the active power. So how exactly it will be means? So here you are measuring the power means you must have measure the voltage and current, right? You must measure the voltage and current. Right. So how it will be? So here you have meter. So in this similarly, if you have ammeter, you have two terminals, right? So positive or negative thing. Similarly for voltmeter, positive or negative thing. So these meters can be, so we have DC meters will be there or AC meters will be there. So one will measure the AC and one will measure the DC. So usually, so meters which will measure the AC, so obviously they will measure the DC. Okay. So in case of AC, you have only, so this plus minus doesn't matter, right? In case of AC, so this plus minus doesn't matter. But in case of this voltmeter, it may matters. In case of DC, so this plus minus polarity will be matters for you, right? So here, if you want to measure the power, so you must measure the the current that flowing through the circuit and the voltage across that particular element. So it will be something like this. You have four terminals here in wattmeter. You have four terminals. So one is M, L, C, V. M, L, C, V. So you have some AC sources there. Okay. And you have load is there. So how exactly this wattmeter will be there? So you have current coil. You have in wattmeter, there are two coils are there. So one is the current coil also and voltage coil. Sometimes this voltage coil is known as pressure coil. Sometimes they refer this as pressure coil. So you have two coils. One is the current coil and pressure coil. So current coil usually its resistance R is very low. Why very low? Because we are connected in series with the circuits. Ammeter will connect in series and voltmeter will connect in parallel, right? So that is a basic. Agree?
Yes, sir.
Okay. So if you connect a large resistor in series, what will happen? There will be some voltage drop. Okay. So that's why ammeter is having low resistance and voltmeter is having high resistance. Right. So that means, so here you have some some coil is there. So this is how we will represent the coil, and with some small resistance. Right? And this voltage coil is connected across this load. Right? So here also you have one coil is there. It will be connected like this. So this is current coil and this is voltage coil. So current coil is predominantly inductance dominated, right? So that means this resistance is very small, whereas here, so this resistance is very large when compared to the inductance of the circuit. Okay, so that's why we'll represent this as just a inductance, and this is represented as a resistance. Understood how it is changed? So here the resistance is negligible, so here the inductance is negligible. Clear? So this one is the voltage coil, and this one is the current coil. This one is the voltage coil. This one is voltage coil, and the red one is the current coil. So we have terminals. So this is M is for mains, L is for load, C is common, okay, and V is voltage. So here, so this is mains, right? So we are connected to the main side. So these are the main supply. So we have main, M here, M will go here, and this is load here. Okay. So you have load here. And another one, so this is common. So we are measuring the voltage between. So here, so this coil is connected across the load, right? So that means C here, and you have V here, voltage. So we have 4 terminals in the wattmeter. So that is M, L, C, V, right? So this how we exactly will connect is M will go to the main side, so L will go to the load side, and MC are shorted or connected together, right? So that means shorted here, so MC, and this V is for voltage, and it will go to the other end of the circuit. So that basically, so this L and V are directly connected. That means L and V are connected across the load. So this is load.
So C is what again, sir?
C is common. So that means, see, this M and C are connected together. Okay.
Yes, sir.
So that's why it is known as C is common. Okay. See here, this thing is that how exactly, this is how you will measure the volt, right? So how this is V. This is clear to you, right? So this is load here.
Yes, I got it.
So this is M here, L here, and C here. So this is V. So this is common, right? Okay. So that's why it is ML CV. So why it is M? So you have source here and you have load here. So that's why it is. That's simple. Right. So how exactly this wattmeter is represented? So this is current coil and this is voltage coil. So the current coil will represent within some inductance, some winding. So voltage coil will represent with resistance. Why it is? Resistance is dominated here, whereas here this winding resistance is very less. So that's why it represents with some winding. Okay. So this gives you, right, this is a meter. So basically for deflection of that meter, so we have some internal processing with some internal details are there. We have some, especially some course on this electrical measuring techniques. In that you will study different kinds of meters like wattmeter, voltmeter, energy meter, so all those things. We have dedicated courses there. So that is in the details. So you will learn in that course. Just remember this much only for right now. Okay. Clear? So this is the wattmeter. So the wattmeter measure the active power P. So that will measure, basically it will measure VI, VRMS into IRMS cos theta. So this is equal to P. So that is the measure. It will measure P. Okay. If you know the VRMS value, IRMS value, so from that you can calculate the cos theta. Okay, if you know VRMS, IRMS, you can calculate the cos theta. From cos theta, you can calculate the sin theta. So from that, you can calculate the reactive power. Or straight away, you can use the reactive power meters are there. So we have var meters are there. So that also you can use. So this is beautiful introduction. So how to measure the different, how to measure the power using a wattmeter. So basically, you are measuring the voltage and we are measuring the current and we are measuring the phase angle between voltage and current as well. So internally there is some mechanism, right, or some technique, so that measure the voltage angle between what we say voltage angle between voltage and the current. It's clear?
Yes, sir. Clear.
So you have any questions? Any questions? Okay. So we'll stop here. So I'm just trying to